All right, so I decided to start the session with logic gates today, right? Because there is only a very simple theory parts that we have to complete with the second lesson, right? So I hope it's better we go with the logic gates. So then, like at the very last half an hour, let's talk about the second lesson, right? So we discuss about the logic gates and we get to know about the logic gates, right? And we draw some circuits, we draw some truth tables, right? So now we know about the gates for a considerable amount of time, right? And last week we were practicing how to draw the circuits from O's and from no's and nan's, right? So most of you have sent me the answers, right? So I'm trying to draw this particular circuits on behalf of you to make sure that you get it all correct, right? So let me draw these two, then show you how it happens, right? So in case if you got any doubts, you can clear those things out, right? And yeah, so since everyone is in the room, I think if I draw this, it will be a little bit helpful for you if you are struggling in some point of creating these using nans and nos, right? So let me draw it quickly and you can check whether you have taken the concept fully or whether you are like struggling still. And if you're struggling still, what I'm saying is just let me know, right? I'll help you, right? Okay, so I'm going to draw the very first one, right? So very first one is going to be, hold on, I have to clean this. Yeah, it is clean.
OS පටන් ගන්නවද?
නිර්මාණ OS පටන් ගන්නවා අපි සෙකන්ඩ් එක ඉවර වුණාම කියන ගොඩක් වෙලාවට
ඒසාද මේකයි සෙකන්ඩ් එකයි දෙකෙන් මේක මුලින් කරලා සෙකන්ඩ් එක පස්සේ
මේක
කරනවා.
මුලින් කරලා සෙකන්ඩ් එක ඊළඟට යන්නේ.
හරි
right?
හරි. හරි.
ඊට පස්සේ ගොඩක් වෙලාවට next week වල අපිට OS වලට එන්න පුළුවන්. මෙයා බලමු මේකේ ගණන් ටික settle වෙන විදිහ අනුව සෙකන්ඩ් එක ඉවර වුණොත් OS වලට යන්න පුළුවන්.
සාද අරගෙන මේ සෝල්ව් කරන එක තියෙන එක නෑ ලොකුවට. පේලි එහෙම ලියලා අර සෝල්වින් පාර්ට් එක තියෙන්නේ නැද්ද?
මොකද පුතේ මට තේරුනේ.
ඒ කියන්නේ සාර අපි දැන් ගානක් ලියගෙන නිකන් සෝල්ව් කරන්න තියෙනවනේ සර් සම්පූර්ණ ලියලා
මේ ඔයා කියන්නේ logic gates වලද?
ඔව් සර්.
නෑ තාම logic gates වල පුතේ මේ මුල් ටිකනේ අපි මේ කතා බහ කරගෙන යන්නේ. තව තියෙනවා SOP POS ඒ දේවල් ටික ලියා ගන්න ඊට පස්සේ K maps කතා කරන්න ඕනේ. ඒක කරලා තමයි
හරි සර්.
විභාග ගණන් පැත්තට යන්නේ, right?
හරි සර්.
Right. Okay, so yeah, as we discussed, so first I'm going to draw the A dot B bar plus B dot C circuit, right? So let me have the lines over here. So the first circuit, it has 3 lines, A, B, and C. So here I'm drawing those 3 lines, right? And what we are going to draw is A dot B bar plus B dot C bar, right? So first I'm going to draw this in the basic gates, right? So you can have the mapping part with this, right? So if it is going to be A dot B bar right, hold on, first let's go with the B bar part. So first I'm making B bar, then I'm taking a line from A, so through the AND gate, and this is B dot C bar, right? Then I'm going to create C bar and taking the one from here and I'm going to put this through an OR gate. Yeah, this is how the basic gates are being created. Now I'll draw it with the NANDs first, right? To create it with the NAND, so I'm going to take the same thing from B. So I'll put it through a NOT kind of a gate. And then I'm going to take a line from A, and I'm going to send it through an AND gate. Then the output is going to send it through, divided into 2 and send it through another NAND gate. So that represents the AND, right? And likewise, I'm going to create C bar over here. And I'm going to take these two through an AND gate and divided into 2 again and again through an AND gate. Right, so later what I'm going to do is I'm going to send this through an AND gate and another NOT type of gate, and I'm going to send it through something like this, right? And if I name these, so this is the first one, this is the second one. So these are the creation of first and second. And this is the third gate, and this represents the third gate. And if this is the fourth gate, this represents the fourth gate. And this is the fifth gate. These three things represents the fifth gate, right? So that is how we are going to draw the NAND circuit, or like the circuit only by using NANDs. And now we can minimize these things, neither we can simplify this. So how did we simplify that? We consider the places, we consider the places where NOT gates, a NOT gate is fixed in front of another NOT gate, right? So the situations like this, right? Situations like this. So we can get rid of these things, right? So the simplified one is going to be this NAND gate remains. Right, and the line from here is taken. This is drawn, and up to this point, it is being cancelled. And the line from here, it is taken, and this is taken from here. And this part is taken away. So at the end, you'll be having this, right?
So උතන උඩේ NAND gates දෙකක් දාන්න ඕනේ.
කොතනද?
සර් ඔතන අර උඩේ කියන්නේ එලිමිනේට් කරන්න කලින් එකේ.
දැන් මේ 1යි 2යි ඉතිරි වෙනවා කියන එක ක්ලියර් නේද නිර්මාණ?
නෑ මම එලිමිනේට් කරන එක නෙමෙයි අවුල තියෙන්නේ. මේ අර අපි යන්නේ ලොකු සර්කිට් එලිමිනේට් කරන්න කලින් එකේ NAND gates දෙකක් එන්න ඕනේ.
NAND gates දෙකක් එන්න ඕනේ කියන්නේ මට තේරෙන්නේ නෑ නිර්මාණ.
සර් ෆොටෝ එකක් කියන්නද?
දැන් නිර්මාණ කියන්නේ මේ මෙතන තියෙනවට වඩා NAND gates වැඩි වෙන්න ඕනේ කියලාද?
ඔව්.
නෑ
මම අර
නෑ. නෑනේ පුතේ දැන් මේ මං මේ numbers දාලා තියෙන එකටනේ. එක කියන not gate එක represent වෙන්නේ එක කියන AND gate එකෙන්. 3 කියන AND gate එක represent වෙන්නේ 3 කියන NAND gates දෙකෙන්. හරි. 4 කියන AND gate එක represent වෙන්නේ 4 කියන NAND gates දෙකෙන්. 5 කියන OR gate එක represent වෙන්නේ 5 කියන NAND gates තුනෙන්.
සර් මං කරලා තියෙන සර 3 කියන ගේට් එක තියෙන්නේ.
ඔව්.
ඒක සර් මං හිතන්නේ එතෙන්ට දෙකක් දාලා තියෙන්නේ.
එතන එහෙනම් ඔයාගේ drawing එකේ වැරද්දක් කරගෙන නිර්මාණ තියෙන්නේ. Right? ඔයා drawing එක මට කෝකටද පොඩ්ඩක් එවන්නකෝ මම බලන්න. Right? So what you are left with is first one and second one is there. Third and fourth one is there. The other third and fourth is gone. And 2/5 are gone. And this fifth one is remaining. Right? So this is the way that we are going to draw a particular expression from NAND gates and simplify it. Everyone, please give me a confirmation. Is that clear with you? Then මේ වෙනකොට ඕක clear වෙලා තියෙන්න ඕනේ ඔයගලන්ට. Right? නෑ මේ නිර්මාණ මේවා අඳින්නේ දෙවෙනි එකනේ. මම මේ ඇඳලා තියෙන්නේ පළවෙනි එකට නිර්මාණ. ඔයා මේ දෙවෙනි එකේ නිර්මාණ මට එවලා තියෙන්නේ.
හරි සර් හරි. ඒක තමයි.
හරි නේද?
හරි සර්.
හරි.
පළවෙනි එක හරි සර්. හරි.
ඔව්. ඔව්. right කලබල වෙන්න එපා. right හරි. okay. So yeah. Yes. So how about others? I got the confirmation from Lalindi, Sachintani and Nikini. How about others? Pahanmi and Nirmana is okay. Akila? Akila, could you go through the video recordings, Puta?
Not yet, sir.
Not yet, neither. පොඩ්ඩක් එතකොට ඔයාට මේක confusing වෙන්න පුළුවන් පුතේ. It's better you go as soon as possible, huh?
Okay, sir.
Right? Okay. Pahan Midua? This is clear. Right, okay. Right, okay. All right. So this is the A dot B bar, B dot C bar circuit. Right? So if anyone got anything wrong, I'll give you a minute so you can draw this. May numbers දාගන්න යන්න එපා. I was referring the numbers for your convenience. Right? ඒක තේරුම් ගන්න ලේසි වෙන්නයි මම numbers දාලා තියෙන්නේ. ඔයගොල්ලෝ numbers දානවා නම් pencil එකකින් දාගන්න, but don't do it in the examination, right? It will be the marker will get confused and he will put the incorrect. He will mark it as an incorrect one, right? So just have the reference and just complete it, right? I'll give you a minute, so please cover it up, people. Right. So I'll go for the second one, which is A bar plus B, B bar plus C. So A bar plus B, B bar plus C. right? So this is the requirement. So is it the same one? Yeah, yes. A bar plus B, B bar plus C, yes. So this is the requirement. So it's A, B, and C. Right, so first I'm going to take A bar. So A bar and the B. Right, then the B bar. And the C. Right, and here we have an AND gate to have the output. Right, so now we are going to draw this using NAND gates. Right, so I'm going to do the same thing. I'm taking a line from A and I'm sending it through an AND gate, not type of NAND gate. And I'm taking a line from B. Now I'm sending it through a NAND gate, and this from the NAND gate again. Right, and those two is sending through another NAND gate that represent an OR gate, right? And for B bar and C, I'm going to do the same, right? So I'm taking a line from B bar and send it through an AND gate, and I'm taking it from C and I'm sending it through here, as well as I'm sending it through here and through an AND gate. So that's OR gate is done. So now I have only AND gate to overcome. So I put these two things over an AND gate. Right. And again, the output, I'm going to throw it through another NAND gate. So what I have done is, this is 1, this is 2. So these are the 1 and 2 representation. This is 3. These are the third representation. If this is 4, this is number 4 representation. And if this is 5, this is number 5 representation, right? And as the very same way, we can get rid of these things using where we find the things in this manner. So like NOT circuit staying in front of another NOT circuit, right? So these two can be taken out. So I'm going to draw the final one. So here we go. This line continues to this level. And the B is having a NOT kind of one. So it continues and having this. So the same way, this line continues, and the lower one as this, right? And we can have these as it is, right? So you are going to lose 1 and 2, right? As well as 1 from 3 and 1 from 4. So this is 3 remaining, this is 4 remaining, right? And this is 3 as well as this is 4. These are 5s, right? So it is going to be the simplified one from the NAND gates, right? So again, I'm giving you a minute to cover up the things, right? If you have gone wrong with something, just take a minute and do the corrections, right? Right. So let's move with the other things, right? So we have done the circuits from NANDs for both the equations, right? And I'm going to show you how we are going to draw it from the nose for both the equations, right? So I'm going to do it right over here. Right, so let me do it again. A dot b bar plus b dot c bar. So I'm going to have same lines a, b, and c, right? So I'm going to draw the basic circuit quickly. And b dot c bar. Right, so we need an OR gate. Right, so this is the basic gate again, and now we are going to draw it using NOR gates, right? Right, so here we go. So not get is created. So then we are going to create the AND gate using nose. Right, here it goes. Right, so it is created. And this is the way we are going to create the OR gate. Right. So let's mark the names. This is 1 and this is 2 and this is 1 and this is 2. So this is 3. So this is 3 and this is 4. These three things are 4. If this is 5, these two things represents that 5. Right. So the same rule applies. These two can be cancelled because it is the same kind of gates. Same kind mean like the only the not, right? Fixing in front of another not. Right, here it comes again. Right. So right, here we go. Right, so this will remain in. Oops. Right, so in the lower part goes the same way. Right, so it goes like this. I think I have missed something. Yes, this should goes over here. Right, and this is going to be reduced like this. And this goes like this. And it goes through another OR gate. So here it comes like this, right? So what we are left with, 1 and 3 is gone, and this 3 and this 3 is staying. This 4 and this 4 stays, and the 5s are stays, right? So here it goes. This is the way we are going to draw the simplified OR circuit to the very first expression, which is A dot B bar plus B dot C bar. Yeah, everyone, again, please confirm whether this is clear with you or not. Right, okay. Right, great. All right, so I'm not going to go for draw the A bar plus B thing, or may I? Let's draw it quickly, right? So that will be clear for you, right? Right, so it's going to be A plus B bar and B bar plus C. So we have A, B, and C. Right. A plus B bar. Let me create B bar. So A plus B bar. And B bar plus C. Let me create B bar. Was it B bar plus C, people? A plus, oh, I'm sorry, my mistake. It is A bar plus B and B bar plus C. I'm sorry. It's going to be A bar B bar plus C. So this is B bar and this is C. Right, later we send it through the AND gate. Right, so A bar, when we are trying to draw this using NOR gates, this is how A bar is created. And this is how A bar and B is created. A bar plus B, I'm sorry. A bar plus B is created. So this is the way. And this is how B bar is created. And And this is how b bar plus c is going to create. And then we are going to create the AND gate. So to create AND gate, we are using an AND circuit. And now we are sending it through another NOR gate. Right, so this is 1, this is 2, so this is 1 and this is 2, this is 3, and these 2 belongs to 3, representation of 3. This is 4 and these 2, representation of 4. This is 5 and these are representations of 5. So in this case, these are the couples that's going to get cancelled, right? So we are going to draw the simplified one right beneath. Right, so here it goes. Right, this one is there. And this goes. This one is there. And this goes. So the cancelled ones will be represented by a line. So finally, we have this. Right, so we are left with 1 and 2, as well as 3 and 4. The other 3 and 4 is cancelled, as well as 2 from 5. So the 1 5 is left with. Right, so it is the way that we are going to have this in NOR gates. Right, so I'll give you a minute to copy this thing down in case if you miss it, and I'll give you another minute to the other one. So then after we can move to the other part. So today we are going to talk about some Boolean algebra, right? So how we are going to deal with some expressions, right? So I'll give you a minute. If you got anything incorrect in this drawing, just make it correct. Okay, I'm moving downwards. Please indicate me if there is anyone still writing or drawing it. Right, this is the next circuit for a bar plus b dot b bar plus c. Okay. Right. So everyone, I think you are done with these things. So let's move to the today's part. We are going to get to know about the Boolean algebra and some simplifications using the Boolean algebra. So first we have some laws to get to close with. Then we are going to have those big expressions, and we try to simplify that big expressions into a smaller ones, right? So some calculations actually, it's algebraic type, right? Okay, so let's move slowly, right? And in your tute, right, you got these Boolean algebraic laws, right? Let me take it. So we talked about these things. We talked about the drawings. We talked about universals. And here comes the Boolean algebra. All right. Okay, so the Boolean algebra is it is just describing about how we are going to deal with a particular logical expression, and how we are going to simplify that particular logical expression, right? So in Boolean algebra, you have to have the knowledge about this postulates. We call it axioms as well, right? So those are very simple stuff, right? Something we know from our truth tables. 0.0 is a 0. 1 plus 1 is a 1 according to the Boolean algebra. 1.1 is again 1. 0 plus 0 is 0, right? So in here, like but they are trying to say from the fifth and the sixth ones, like from this, they are trying to say like 0.1 can be write as 1.0. Now maru kalla liyanna puluwan, and the answer is going to be 0. So the same way 0 plus 1 can be changed as 1 plus 0, and the answer is going to be 1 anyway. Right, so the very last two things, it says when x is 0, x bar is definitely 1, right? Something we know, right? And x is 1, x bar is complete. Definitely it's going to be a 0, right? Axioms are very easy. Like actually we don't have nothing to worry or to remember about these things. And when it comes to the Boolean laws and theorems, there are some things that we have to remember, right? But again, these things are less in number, right? So this is the way it goes. So I think you can see it in your handout. In page number 12, we got something called commutative law, right? So commutative law explains that we can toggle the variables around a particular operator, right? But remember, it is around a particular operator, right? And there are some ways that we have to remember that, like in some incidents, we have some restrictions as well of toggling the things, right? So in the commutative law, they say if your terms are separated by the similar operator, right? So those should be separated by the similar operator, then you can toggle the variables around the operators, right? So they have simply shown you an example saying x dot y equals to y dot x, right? So I'm sorry, this is not the thing I want, right? So this means if you got this in this manner, දුවල පුතාලා මේක ඔයගලගේ note එකේ ලියා, Kahoot එකේ ලියාගත්තට කමක් නැහැ, මේවා possible මේවා impossible කියන එක, right? So if you take x dot y dot z, this can be written as x dot z dot y or y dot z dot x. It is possible, right? And again, x plus y plus z, that can be written as x plus z plus y, because every variable is separated from the similar operator, right? Y plus z plus x, yes, that is possible. But what are the things impossible around here? Now, if you got something like this, x plus y dot z, now you can't toggle the operands in between, like besides the plus, ධන ලකුණු දෙපැත්තේ තියෙන operands එහෙ මෙහෙ කරන්න බෑ. ඒ කවුරු හරි එක්කෙනෙක් තව dot එකක් එක්ක බැඳිලා ඉන්නවනම්, if that variable is staying with or like bounded with the dot operator. If it is bounded with the dot operator, this big thing or like this, the dot operator keeps everything together. Plus operator separate the things, right? So you can write this in this manner, x plus z dot y. Yeah, that is possible. This is correct.
Sir.
But if you write it like this, y plus x dot z, completely wrong, right? So the reason is you can't take some variable from which is been binded with a dot operator. Dot operator එකේ තියෙනකොට කැලලක් ගලවලා අරගෙන plus එකක් එක්ක කවලම් කරන්න බෑ. Right? Always remember the dot operator keeps things together. Right? But if you got something like this, x plus y brackets, then dot z. Now, of course, you can say y plus x dot z. So the same thing happens when the brackets are there. Brackets are the strongest part which can hold a term together. Right? Brackets තිබ්බොත් brackets ඇතුලේ ඉන්න කට්ටිය එකට ඉන්න. Brackets නැති වුණොත් dot operator එකත් එක්ක ඉන්න කට්ටිය එක bundle එකක් විදිහට ඉන්න.
Sir, මාව ඇහෙනවද?
ඔව් කියන්න නිර්මාණ එනවා.
ඒතකොට ඩොට් වී ප්ලස් අපිට එකට දැම්මට ඔය ලෝ එකේ හිටිය ප්‍රශ්න නැද්ද? ඩොට් එකයි ප්ලස් එකයි.
එකට දාන එකද?
ඔව්.
නෑ
ඔය ලෝ
එහෙම
එකේ
නෑ මෙහෙම ලියන එක මෙහෙම එක්ස්ප්‍රෙෂන් කරන එක ගැටලුවක් නෑ නිර්මාණ.
හරි සර්.
right but අර අපි දැන් මේ ටොගල් කරනකොට මේවා මාරු කරනකොට මේ මම පෙන්නලා තියෙන විදිහට විතරයි මාරු කරගන්න පුළුවන් වෙන්නේ.
හරි සර්.
right දැන් ඔයගොල්ලෝ මේක ලියන්න හැදුවොත් මෙහෙම මේක හරි y plus z dot x කියලා so that is wrong right මොකද එතකොට මේ dot එක ගාව ඉන්න කෙනා ඇතුළට දාලා x එළියට දාන that is wrong that cannot be right because
ඩොට් එක ගාව ඉන්න කෙනෙක් ප්ලස් කරන්න බෑනේ කොයි වෙලාවකත් නේ සර්. ඒ කියන්නේ ඩොට් එක ගාව ඉන්න දෙක ඩොට්මයි ප්ලස් එක එහෙමනේ.
අන්න right හරි එතකොට හොඳට මතක තියාගන්න brackets දීලා නැත්නම් යම් කිසි තැනක dot is the operator which holds the things together dot එකෙන් දේවල් ගලවලා වෙන් කරගන්න බෑ අපිට එහෙම වෙන් කරගන්න පුළුවන් තැනක් එනවා හැම තැනම ඒ જાතියේ කට්ටිය ඉන්නවා which we call the common terms right පොදු පද කියලා අපි කියන්නේ එහෙම පුළුවන් right so commutative law is a simple thing which allow you to toggle the variables around an operator right okay are we clear with this everyone can I have the confirmation please okay all right so then you are having another law called associative law right it is talking about the things inside the brackets and still look at the operators the operators are similar right ekama jatiye operators thiyene identical operators right here you got a dot and another dot here you got a plus and another plus so again associative law says if the operators in between the terms are identical you can move the brackets move karanna puluwan eheta meheta right so x dot y dot is said in brackets so everything is dot so you can move the brackets so x plus y plus is said inside the brackets so everything is plus so you can have x plus y as the brackets plus z right so again remember it is only when the operators are identical in between each other right now these two laws are like something very simple neither we don't need to remember it specifically but all you have to remember the point the operators should be identical in between the variables for you to toggle or for you to move your brackets here and there right
සර්
oh nirvana
ඔයගරද්දි මාරු ගන්න බෑනේ. ඒ කියන්නේ අපි associate law එකේ කියන්නේ dot v plus එකට combine කරන්න බෑනේ.
බෑ ඒකයි මම කිව්වේ මේ operators identical වෙන්න ඕන කියලා.
හරි සර්. හරි.
identical නම් තමයි ඔයාට වරහන් එහෙ මෙහෙ ගෙනියන්න පුළුවන්. right ඒකෙන් අදහස් වෙන්නේ නැහැ dot v plus දාන්න බෑ කියන එක. right දාන්න පුළුවන්. වරහන් move කරන්න වෙන්නේ අර කියන basis එකට අදාළව.
එතකොට සර් වරහන් නැතුවත් වෙනවද associate law එක?
නෑ වරහන් නැතු වෙන්නේ නෑනේ associative law එක එන්නේ වරහන් වල තියෙන movement එක ගැන කියන්නේ.
හරි සර්.
right වරහන් නැතු වෙන්නේ නෑ. okay so then we are going to talk about the distributive law. Now here you have something to learn like you may have learned one of the distributive laws from your mathematics, from the mathematics subject, in the mathematics subject, right? But there is a distributive law which teaches you a different way of thinking the distribution, right? So if you think about the very first theory of the distributive law, so it says x dot y plus z. Y plus z is inside the brackets, right? So what they have done here, they have considered this x and multiply the things inside the bracket from the x, right? So I'll go again. X is the one inside, x is the one who is staying outside. So it multiplies the things inside the bracket. So it gives x dot y, the first multiplication, and a plus, then x dot z, the second multiplication, right? So this plus staying over here. Right? Did you got that, people? So we can apply this in the reverse way as well. Now, if you consider this part of the law, so this term alone has a x and this term alone has another x, right? So we can take the x out. Once we take something out as a common term, brackets are applied automatically. So y is remaining from the first term plus z is remaining from the second term, right? Which gives you this again, right? So we are heavily use this practice, right? Actually, this one, when we are like resolving the things or like simplifying the things, right? So that is distributive law.
So උතන multiply වෙන හන්දද මේ කියන්නේ x dot brackets y plus z කියලානේ තියෙන්නේ.
Oh.
Final එක ගද්දි x dot y
මෙතන අහන්නේ මෙතන dot එක එන්නේ නැද්ද කියලාද?
නෑ නෑ, ඒ කියන්නේ අතන x ගාව dot එක තිබ්බ හන්දනේ අපි multiply කරනකොට ඒ කියන්නේ plus එක අයින් වුනේ.
plus එක අයින් වුනේ කොතනද පුතේ?
ඒ කියන්නේ දැන් අර x dot y කියලානේ තියෙන්නේ.
ඔව්.
මෙතන හරි මේ නෑ මම ඒක තේරුම් ගත්තා. දැන් හරි ඒ කියන්නේ අර x ගේ multiply වලානේ එන්නේ.
ඔව් මෙතන plus එක ඉතිරි වෙනවා. මෙතන plus එක තියෙනවා.
හරි.
Right. හරි. So the second one. Now the second theory is little bit weird, right? Weird, කිව්වට ඒක weird නැහැ. But there is a logic, but it happens in a different manner, right? Now I'll take your concentration into this first. Now for this side, we can apply the distributive law. What happens if we apply distributive law to these two? මෙතන වරහන් දෙකක් තියෙන්නේ. වරහන් දෙකක් තියෙනකොට distributive law එක apply කරන්නේ මෙහෙමයි. A one component is multiplied with the other bracket. Then the next component is multiplied with the other bracket again. Right? So this is going to give you x dot x. This is going to give you x dot x. This is going to give you x dot z. So we say plus x dot z. And again a plus, then the y part, y dot x plus y dot z. Did you notice that? how the things are happening? Right, people, is that clear? The how the multiplication has happened? Right, okay. So later in this identity law, identity නෙවෙයි අතරම අපි මෙයාට තව අලුත් නමක් මෙතනදී indicate කරනවා idempotent law කියලා. මෙතනදී අපි ඒක category කරගන්නවා. Right, now look at this. This says x dot x can be considered as x. ඒ කියන්නේ එකම ජාතියේ කෙනෙක් ඒ ජාතියේ කෙනෙක් එක්ක multiply වුණාම උත්තරේ එන්නේ ඒ ජාතියේ කෙනෙක්ම. Right, like we know that 1.1 gives you 1 and 0.0 gives you the 0. So when identical things are being multiplied, it's going to produce you the same one. Right, so we say x dot x equals to x. X dot
So then x plus y කියලා එකක් එන්නේ නැද්ද?
කොතනද
x plus y කියලා.
x plus y කියලා එකක් එන්නේ නැහැ. Distributive එකේ වෙන්නේ පුතේ මම මේ අර මේ ඔයාට ඊතල ගහලා තියෙනවා වගේ පද හතරක් හැදෙන එක. ඒක ඔක්කොම හැදෙන්නේ multiplications. ඒ හැම multiplication එකක්ම වෙන් වෙන්නේ pluses වලින්.
ඒ කියන්නේ අර පැත්තේ bracket එකේ තියෙනවා අනිත් bracket එකෙන් multiply කරපගෙන කරන්නේ.
ඔව්, ඒ කියන්නේ එක bracket එකක ඔයා එක term එකකින් term එක සලකුවා. එක variable එකකින් variable එක අරගෙන අනිත් bracket එක totally multiply කරා.
හරි.
හරි. So this gives you y dot x. This gives you y dot z. Now you can see I've got x here and x over here as well as x over here. So I can take that as a common term as we take it from here. So it's x dot. Since I take in the x from this point, it will goes with 1. Plus, since x is gone from here, z remains. Plus, since this x is gone from here, y remains. Then close in the bracket because I was asking from those three terms, and y dot z remains. Right, and from this theory, it says x plus 1 equals 1. So that means 1 plus z is going to be 1. Later 1 plus y is going to be 1 as well. Right, so that means this entire thing is going to become a 1. Because when we add the variables into 1, it's going to give you a 1 always. Right? So that means you are going to have something like this. X dot 1 within brackets plus y dot z. Now from here it says x dot 1 equals to x. So this means x plus y dot z, which is the left hand side of your equation or the law. Right, අපිට ඔහොම පෙන්නන්න පුළුවන්. ඒක තේරුණාද හැමෝටම? Can I have the confirmation how these two things are?
So x plus y dot z කියන එක ගත්තේ identity law එකට අනුව නේද?
ඔව්, ඒ කියන්නේ මෙතන මේ x dot 1 එකට මම x කියලා ගත්තා. මේ මෙතන x dot 1 එක x කියලා එනවනේ.
ඔව්.
ඒක නිසා මේක මම x කියලා ගත්තා. y dot z එක ඒ විදිහටම තියෙනවා.
හරි සර් හරි.
Right. Okay. දැන් ඔය මේ සිද්ධිය සිද්ධ වෙන විදිහනේ. මේක එක සැරේ ලියා ගන්න පුළුවන් ක්‍රමයක් තියෙනවා මම ඔයගලන්ට කියන්නම්. And I'm going to get rid of these things first. Right. Right now, the relationship between these two terms, right, these two sides are going to be like this. Right? Now, look closely. I'm rounding some area, right? I'm taking this x plus alone. So you can see x plus over here as well as x plus over here. Then this y is staying here, this z is staying here. Right? So this dot comes over here. Right? So that means if something is alone and you are doing an O operation with a bundle which is doing the AND operation together, x alone in or y dot z එක AND operation එකක් තියාගෙන ඉන්නේ. So we can decompose those x plus y, the part of the multiplication, dot x plus z, the other part of the multiplication. Is that clear? Yes, everyone? Is that clear? Okay, how about others? Sachintani, yes. I'll go with that doer. Shall I go with the another example doer? Right, I'm taking the example like this. Let's say P plus Q dot R. Now I can write this. First I write P plus. P plus. Right, and I'm taking this Q over here and I'm taking this R over here. And
සර්
this
එතකොට අපි
dot
ගානකදී ඔක මේ ඇප්ලයි කරන්න පුළුවන් නේද ඔය විදිහට?
කෙලින්ම පුළුවන්, කිසිම ප්‍රශ්නයක් නැහැ. මෙහෙම මේ විදිහට තියෙන එකකට එක සැරේ මේ පැත්ත ලියන්න පුළුවන්. Sachintani, was it clear? Lalindi, how about it? Right, okay. So that is why I told you the second method of the distribution is a little bit weird. We have to remember that. මෙහෙමයි වෙන්නේ කියන එක, right? So in your handout, it's better you put a star mark or something to this second distributive law. Right there, that star will indicate there is something for you to understand specially in this law. Right? Okay, so now we are moving to the identity laws. Actually, identity law, later they have divided these laws into a small kind of laws again, right? So I'm going to give you the names now, right? So identity law, they are considered the identity laws by regarding these four. Now these four only represents the identity laws. Right? And they later introduce these type of things. X bar dot x bar equals x bar. X bar plus x bar equals x bar. Right? I'll take this law onto the top of this. X plus x equals x. Huh. Now look at this. Can you find any pattern inside this? So left hand side, it has identical variables. X is added with an x. X is multiplied with another x. X bar is multiplied with x bar, and again x bar is added with another x bar. Right? So it says when identical variables are add up, that means or doing the operation, or multiplied, that means doing the AND operation, it's going to produce the same thing, the same variable, the same value, right? X plus x is x. X dot x is going to be x again. So same applies with the x bars. X bar dot x bar is x bar. Yes, Nirman.
x bar dot x bar කොහොමද x bar එකක් වෙනස x එකක් වෙන්න ඕනේ.
Then දැන් ඔය double bar එක පටලගෙන තියෙන්නේ. X bar dot x bar x double bar වෙන්නේ නැහැ කවදාවත්.
හරි සර්.
හරි. එතකොට x bar dot x bar means x bar. ඔතනදී මතක තියාගන්න තියෙන logic එක තමයි එකම જાතිය අය නම් ඉන්නේ එකතු කරත් ගුණ කරත්. right? ඒ කියන්නේ operation එක කරත් and operation එක කරත් result එක වෙන්නේ ඒ જાතියේම එක්කෙනෙක් කියන එක. Right? Identical window. Right? So these things are called idempotent laws. Right? Idempotent law. Right? So I want you to do the changes. If you don't have the handout with you, please like indicate on a particular paper. Right? I think Akila does not have the tute. Neda Akila? Akila gava tute එක නෑ නේද?
නෑ සර්.
Akila ඇවිල්ලා collect කරගන්න පුළුවන්ද පුතේ ඔයාට? From
Yes,
where, like from where are you from, පුතා? Akila, are you from like near around Tower?
Sorry, sir.
Are you from near around Tower?
Yes, sir. Maharang.
You're from Maharagam, right?
Yes, sir.
All right. Okay. So it's better if you can come and collect the tute because it is important. So I got all four tutes. I'll let you have those
Yes,
things, right? Okay. So this is called the idempotent law, right? Okay. So I'm cutting this down because I've written it over there. Right, now we are left with three more things. Right, now these are called, these two are called inverse law, or sometimes they call complement laws. Right, inverse or complement laws. Right, now what's going on with the inverse and the complement? Now it is talking about a variable doing the AND operation. The first law says the variable doing an AND operation with its complement. The x කියන කෙනා එයාගේ complement එක x bar. So x is doing the AND operation with its complement. That means x bar. So it's going to give you a 0. එතකොට කොහේ හරි expression එකක ඔයා මේක දැක්කොත් x dot x bar දැක්කොත් you can apply 0 for that particular position. Right? And oppositely, if a particular variable doing a O operation with its complement, it's going to produce you a 1. Right? There simplification වල මේගොල්ලෝ හරි වැදගත්. Right? මේගොල්ලෝ හරියට උදව් වෙනවා ඔයගලන්ගේ simplification process එක ඉක්මන් කරන්න සහ ලොකු expression එක simplify වෙන්න. Right? So all you have to do is you have to remember what this is. Right? දැන් මම අද මේක කියලා ඉවරනයින් පස්සේ ඉස්සරහට අපි ගණන් හදනවා. එතකොට පොත පෙරලා ඔය ලෝස් ටික බලන්න ඉන්න එපා. පොඩි කොළ තීරුවකට නේද? half sheet කොළ භාගයකට වගේ ඔය ලෝස් ටික හරියට ලියා ගන්න උඩින් ඉඳලා පහළට. එතකොට නිතරම ඔයා ගාන හදනකොට මේ ලෝස් ටික ළඟ තියෙන්න ඕනේ. ඒතර මොනවා හරි ලෝ එකක් අමතක වෙනවා නම් එයාව රිෆර් කරා වැඩේ කරගෙන ගියා. right? ඔයාට පුළුවන් නම් ඔයා නිතරම රිෆර් කරන ලෝ එක මාක් කරගන්න. එතකොට ඔයාට තේරෙනවා ටික දවසක් යනකොට ඔයාට මතක නැත්තෙම මොන ලෝ එකද කියලා. right? Okay. So x dot x bar is 0, x plus x bar is 1. I think you can remember these things. We use these things when we are discussing the universal gates. The universal gate වල output එක එන්නේ කොහොමද කියලා කතා කරනකොට we discuss about this inverse or complement laws. Right? So the final one, this double bar, is called the double complement law or the double inverse law. It is a law. Right? Double complement law. Right? So this is how they have category these. Earlier it was earlier everything is called identity law. Now they have category those things like identity laws, inverse laws, idempotent laws, and double complement laws. Okay. Now double complement law, it is very easy. We know about it. X double bar equals X. We know about it. Right? If X is flow through a NOT gate, it gives you a X bar. If X bar is flowing through another NOT gate, it's give me X double bar. That means X. Right? Okay, people, is it clear up to this point?
සර් double complement කියන්නේ double bar කියන එකද අපි කියන්නේ?
Oh, double complement law එක කියලා කියන්නේ double bar එක කියන එක.
එතකොට x වෙනවනේ ඒ කියන්නේ x bar දෙකක් තිබ්බොත් කෙලිම x වෙනවා.
ඔව්. ඒතර ඔය වගේ එක ළඟ තියෙන්න ඕනේ. Right? Okay. So now we are moving to discuss the other laws, right? Which is in your handout, right? What are the other laws? So you are already familiar with the De Morgan theorem. We were discussing those things in the universal gates. Now the next one, the redundancy or the absorption law, is the one you are messing with in big time, right? මේකත් එක්ක ඕගොල්ලෝ සෑහෙන පටල ගැනීම කරනවා. right? ඒක නිසා මේ redundancy law කියන තැනට නේද? රතු පාටින් කොටු කරලා තරු 10ක් 15ක් දාගත්තත් කමක් නැහැ. ඒ තරමට මෙයා වැදගත් සහ ඒ තරමට මෙයා පටල ගන්නවා හරියට ඕගොල්ලෝ මෙයාගේ pattern එක අඳුනගත්තේ නැති වුණොත්. right? There are 4 types of redundancy laws, and you have to remember how it happens, right? There is a logic behind it, so you don't need to worry, right? Okay, so how these things are being worked, let me see, let me show you. Now redundancy laws, look at the first one. Can you see any common term inside the left hand side? වම්මත පැත්තේ common term එකක් පේනවද? Yes. There are 2 terms, x alone, it is a one term, x dot y is the other term, right? මම කියන්නේ brackets නැති වෙලාවට plus එකෙන් තමයි terms වෙන් කරන්නේ. dot එක තමයි terms ඇදලා තියාගෙන ඉන්නේ, බැඳලා තියාගෙන ඉන්නේ. bracket එකක් නැති වෙලාවට. brackets තිබ්බම මේ කතාව පොඩ්ඩක් වෙනස් වෙනවා. Now you can see there is this x variable in both the terms. So what we can do is we can write the x plus x dot y. We can take the x out, so it will gives me brackets. So 1 is remaining because the only x is taken out, plus y is remaining. And we know what's the value of 1 plus y now, right? In identity laws, it says what? 1 plus y equals 1. We earlier talked about it. This is 1 plus x equals 1, right? So here 1 plus y equals 1, so that means you got x dot 1. That means x dot 1 means x. If we multiply a particular variable by 1, it going to produce you the same variable. Again, it comes from identity law. See, x dot 1 equals x. The mathematics වගේමයි නේ. එකෙන් multiply කරාම එයාමයි. ඔබද?
සයිත් මෙතන මේ තියෙන symbols දෙක plus dot දෙකම තියෙනවානේ. අපිට මේ අරගෙ තිබ්බේ සර් මේ plus විතරයිනේ. කියන්නේ x plus 1 equals 1 කියලානේ තිබ්බේ. දැන් මෙතන සර්
මෙතනද
1 dot y කියලානේ.
ඔව් මෙතනද නිර්මාණ කියන්නේ නිර්මාණ මේ
ස්ක්‍රීන් පළවෙනි රෙඩ් කලර් එකෙන් අන්ඩර්ලයින් කරලා තියෙන්නේ.
මෙතන.
ඔව් සර්. කියන්නේ ඔතන තියෙන සර් ප්ලස් එක විතරයිනේ.
ඔව්.
ඊට රිඩන්ඩන්සි එකේ symbols දෙකම තියෙනවනේ. කියන්නේ plus and dot දෙකම තියෙනවනේ.
ඔව්.
ඒසොල්ට ඒක identity law එකේ කියලා කියන්නේ කොහොමද අපි කියන්නේ? විතර combination එකක් තියෙනවා.
මෙහෙමයි පුතේ. ඒ කියන්නේ අපි මේ දැන් ඔයා මේ කතා කරන්නේ මේ මම මේ රවුන්ඩ් කරන කොටස ගැන නේද?
ඔව් සර්. ඕකයි අරකයි අතර තියෙන කනෙක්ෂන්
සම්බන්ධය. හරි. ඒතර මෙතන x + 1 නේ තියෙන්නේ. එතකොට අපි කරන්නේ අතනින් x + 1 කෙනෙක් හොයනවා.
ඔව් සර්.
මෙතන අපි x එළියට ගත්තම මේ 1 + y කියලා කෙනෙක් අපිට වරහනේ ඉතුරු වුණානේ.
ඔව් සර්.
එතකොට 1 + y කියන කෙනාට තමයි අපි 1 කියලා දාන්නේ. මොකද 1 + y කියන කෙනා මේ වරහන්ට විතරයි. 1 වරහන ඇතුලේ සෙට් එකට 1 + y කියන කෙනා අපිට 1 කියලා රෙප්‍රසන්ට් කරන්න පුළුවන්.
ඔව් සර්.
රයිට්. ඒක නිසා අපි තමයි මෙතනට 1 කියලා දාන්නේ.
හරි සර්. හරි.
තේරුණා? එතකොට අපි එළියේ ඉන්න ඒ විදිහටම ඉන්නවා. මේ ඩොට් එකත් ඒ විදිහටම තියෙනවා. චේන්ජ් වෙන්නේ නැහැ. ඊට පස්සේ අපි identity laws වලින් ගන්නවා x.1 කියන කෙනා. දැන් මෙතනට 1 ඇවිල්ලා ඉන්නේ. ඊට පස්සේ අපි ගන්නවා x.1 කියන කෙනාගෙන් උත්තරේ එන්නේ x කියලා. right? එතකොට මෙතනට x කියන උත්තරේ ඇවිල්ලා. Right? Okay, people, did you get how this law has been implemented? Right? Then ඕගොල්ලන්ගේ විභාගෙදී, if you see something like this, you can straight away write x. You don't need to simplify it like this. You can straight away write the x and you can give the answer or give the reason as like it is the redundancy law. Yeah, people, please confirm. Is it clear?
සර් එතකොට ඔය apply කරද්දී අපි redundancy law කියනත් හතරෙන් එකක් තෝරලා දෙක හරියටම ගන්න.
ඔව් ඒ කියන්නේ කැමැති එක කියන්නේ මොකක් හරි එක සැරයකට එකයි නිර්මාණ ඇප්ලයි කරන්න පුළුවන්. අපිට හතරම අපිට අවශ්‍ය වෙලාවට පාවිච්චි කරන්න පුළුවන්. එහෙම ගැටලුවක් නැහැ. right?
එතකොට හතරෙන්ම පෙන්වන්නේ එකම දෙයක් නේද ඒ කියන්නේ?
නෑ හතරෙන්ම පෙන්වන්නේ එකම දෙයක් නෙමෙයි. හතරෙන් පෙන්වන්නේ දේවල් හතරක්. right? ඒ කියන්නේ result එක වගේ වෙන්න පුළුවන්. දැන් මේ පළවෙනි කෙනාගේ result එකයි දෙවෙනි කෙනාගේ result එකයි එක වගේ.
ඔව්
නමුත් ඒගොල්ලන්ගේ representation වෙනස්.
හරි සර්. හරි සර්.
Okay. Now let's think about the second one. Now second one says x dot inside the brackets x plus y. Right? X dot x plus y. Now x dot x plus y, can't we apply the distributive law for this? That means multiply these two things from the outside. So it gives you x dot x plus x dot y. Right? So you know x dot x equals to x. That is from idempotent law. And x dot y is going to be like that as well. And now you find what? මේකෙන ආවා කියලා කියන්නේ ඒ ඉන්නේ මෙයා. Then the final answer is going to be x again. තේරුණාද? Yes, lamai. Right. Okay. Very good. Now, those are the easy laws of the redundancy. Right? එදෙන තේරුම් ගන්න ලොකු දෙයක් නැහැ. But the මේ දෙන්න ගාව තියෙන patterns දෙක මොකක්ද? Right? Look at the patterns. If we think about the patterns, දැන් අපිට මොකද patterns තමයි ඕන වෙන්නේ මේ simplify කරනකොට. එකපාරට law එක මතක් කරගන්නවා කියලා කියන්නේ pattern එක මතක් කරගත්තා නම් හරි. So here x is alone doing the plus operation with again x with someone else. Right? ඔන්න ඔය nature එක තියෙනවා නම් we can straight away write x. And the other one, the x is alone, x and y is doing the operation. So still the answer is going to be x. So පද දෙකක් තියෙනවා නම් terms දෙකක් තියෙනවා නම් දෙකේම x වගේ එක්කෙනා ඉන්න ඕනේ similar situation. Right? Okay. Now the last two things. So here we got a particular rational or particular argument that we can create. Right? What is the argument that you are going to create? Look at this. The x is staying alone. He is alone. And x complement x complement is with someone else. Right, so that means when we are writing or when we are simplifying it into the as per the Boolean algebra, we can omit this x bar and we can write just x plus y.
So අපි x bar එක අයින් කරනවා කියලා හරියටම හොයාගන්නේ කොහොමද ඒ කියන්නේ?
හොයාගන්නේ ඔයාගේ මේ වෙනම ඉන්න තැන කවුරු හරි කෙනෙක් ඉන්නවනේ. එයා ඊළඟ එකේදී කම්ප්ලිමන්ට් වෙලා තියෙන්න ඕනේ සහ තව කෙනෙක් එක්ක ඉන්න ඕනේ. තේරුණාද මම?
ඔව් සර්.
Right, so on that occasions we can take x plus y. All right, then the other way around, right? It has the same logic. X is alone and the yeah, let's write this. X is alone and the complement of x doing plus operation with y. So in that case, we can disregard of x bar again, but now we are left with a dot. Right? දැන් මොකද මෙතන x bar dot y තියෙනකොට dot එක සලකුවේ නැහැනේ අපි. So same happens over here. Right? X right, so we can go with x dot y over here, right? We forget the x bar, right? And along with plus. Okay, are we clear? So
Clear, sir.
second example again, like third and fourth laws wala, like you will try to find out something alone, and if you see that one's complement is staying with something else, so you can apply either the third law or the fourth law according to the operators that they have using. Okay, how about others? Is that clear? Right. Okay. All right. So the very last law, we know about it, the De Morgan's theorem. So x dot y bar. So this x dot y bar can be represented as this as well, x dot y total bar. Here they have given as x dot y dash. Can be written as x bar dot become a plus, then y bar. Right, so that big bar is separated or like decomposed into these small bars and then asked to convert the dot into a plus. And the similar way, x plus y total bar, it is changed as x bar dot y bar. Right? Is that clear, people?
සෙදර ඔක්කොගේම ලෝස් වලින් ගත්තාම ඩී මෝගන්ස් එකේ විතරයි නේද මේක මාරු වෙන්නේ. කියන්නේ මල්ටිප්ලිකේෂන් තිබ්බොත් ප්ලස් වෙන්නේ.
ඔව්. එහෙම වෙන්නේ බා එක දෙකට කැඩෙන නිසා.
හරි සර්. ක්ලියර්.
Okay. So people now get ready. We are going to do some simple simplifications using this, right? So you know now the details. We'll slowly get into this, right? So I'm going to give you some questions. better go with the simplifications, right? Hold on a second. Yeah, here we go. Right, let's do it over here. All right. These are the questions that we have to go through. So started from the very first one, A dot B plus A dot B bar, right? So what you are going to do is you are trying to simplify this, right? So when you are simplifying, remember these facts. If you got the theory, if the expression has some places where you can apply theory as it is, so go for that. කෙලින්ම පේන්න තියෙනවා නම් theory එක දාන්න පුළුවන් කියලා. So apply it and get it simplified. If you
සර්
do
මෙතන ලෝස් දෙකක් ගන්න වෙන වෙලාව තියෙනවද?
ඔව් පුළුවන්. දෙක තුන ඕන ගානක් ගන්න පුළුවන් වෙනවා. එකෙන්ම විතරක් අපිට කරන්න බෑ නේද? Right? So if you can't find the direct places, then the best way is to try to find out some common terms, because common terms will help you to reduce the big things, right, or the big expressions, right? Or else just see whether you can apply the De Morgans and do the difference, right? Are dekama natta, right? Okay, so give it a shot, people. Give a try to the very first one. I'm going to do it. Yeah, since it is the first time, I'm going to do it within 5 minutes. It's 1:12. I'm going to do it by 1:17. If you do your first one, so you can proceed to the second one, third one, likewise.
සර් සෙකන්ඩ් එකේ ගත්තාම සර් දැන් ඒ කොමන් නේ.
Oh,
එතකොට B plus C කියලා ඒතකොට අපිට රිඩන්ඩන්සි ගන්න පුළුවන් නේද?
then B plus C redundancy ගත්තොත්
ඇයි සර්?
කොහොමද
ඒ-
දාන්නේ?
ඒ- ඇයි සර් කෙලින්ම තියෙනවා x dot ඒක රිඩන්ඩන්සි ලෝ එක.
නෑනේ, redundancy එකේදී කියන්නේ x එළියෙන් ඉන්නවා dot වරහන් ඇතුලේ x ම ඉන්න ඕනේ.
හරි සර්.
A වරහන් ඇතුලේ A තියෙනවා. සෙකන්ඩ් එකට ඔයගලන්ට මුකුත් කරන්න බෑ. ඒක නිකන් distributive law එක apply කරන එක විතරයි කරන්න පුළුවන්.
ඩිස්ට්‍රිබියුටිව් පුළුවන් නේ සර්.
Distributive පුළුවන්. Yes, distributive.
හරි සර්.
Oh.
අපිට හතරට කමියුනිකේටිව් එක ගන්න පුළුවන් නේද?
කමියුටේටිව් ගන්න පුළුවන්. හැබැයි කමියුටේටිව් වලින් සිම්ප්ලිෆයි වෙනවා කියන දෙයක් වෙන්නේ නැහැ. හොඳ. අපි සාමාන්‍ය සිම්ප්ලිෆයි කරනකොට නිර්මාණ අපිට ගොඩක් ඕන වෙන්නේ identity laws, idempotent laws. ඒ කියන්නේ commutative associative ඉන්නේ අපිට පද මාරු කරගන්න.
එතකොට මේ ඔතන මම ඒක හිතුව ඔතන වේරියබල් දෙක වෙනස් හන්ද ඒ .b කියලා තියෙන හන්ද මම ඒක හිතුවේ. හරි සමහර බලන්න.
බලන්න. Okay, so let me try this. Right, so the first one, it's a simple calculation we have to do. So let me do the first one. So it says A dot B plus A dot B bar. So I can see A is common in these two terms. So I'm taking A out, which leaves B plus B bar inside the brackets. So when we are doing this simplification, it is a must to write what is the law that we have used. So we have to say it's better you show the particular law. Namaliyanne wata wada law එක ලියලා පෙන්නන එක තමයි ඒගොල්ලෝ කැමති වෙන්නේ. Right? So here we use distributive law. So we can say x dot y plus z equals x dot y plus x dot z. That is the reason. So b plus b bar, you know, from the inverse laws, it is 1. So a dot 1 over here. So the reason is x plus x bar equals 1. So the final answer is going to be A. The reason is x dot 1 equals x. Right? So this is how we are going to finish up a simplification. Right? So this is the first one. Okay, people, is this clear? Right, okay. All right. So copy it down and do the correction if you find anything wrong. And meanwhile, I'll do the second one. Second one, there is not much to change. So it says A dot B plus C. It's clear we have to apply the distributive law. So we can say A dot B plus A dot C. That's the only thing that we can do to this. So the reason is, again, the distributive law. So we'll write it and show it. Right. And you may try the third one. I'll do it within another 2 minutes. All right, I'm giving a try to the third one. So third one contains A plus B dot B bar plus C, or B dash plus C. right? So we can't find any common terms, because common terms can be found out from the places where we can find the dots. Oh, what's happened here? Yes, so what's the problem, Susu? Right? Oh, don't worry. So we are going to apply the distributive law. Yes, that's a bumblebee. I'll come, right?
Daddy, did you set a bumblebee flying with this one?
No.
But it's still here.
Huh. We'll do the play, right? We'll see the bumblebee once I'm done. Huh?
But those birds are still.
Go and get ready with me. I'll come. So we are applying the distributive law. Since we do not have a particular the common terms to be taken out, right? Common terms අරගන්න පුළුවන් වෙන්නේ මේ dots එක බෙදලා තියෙන තැන් වලින් විතරයි, right? So we can apply the distributive law, right? So from A, I'm going to multiply these two. So I'm going to have A dot B bar plus A dot C, and then I'm going to multiply by B these two. So it's B dot B bar plus B dot C. So the reason is distributive law. So I'm writing it like this. Now I can see this is equals to a 0, right? So I can take A dot B bar plus A dot C plus B dot, I'm sorry, plus 0 plus B dot C. So this indicates X dot X bar equals 0. And then I can write the final answer as A dot B bar plus A dot C plus B dot C. The reason is X plus 0 is X, right? So you can't simplify this further than that, right? So you can stop doing your simplification from this point, right?
So then අපි distributive law එක නේද apply කරේ.
Oh,
තුන්වෙනි එක හරි සර්.
right. Right, so meanwhile you can try the fourth one. Let's do the fourth one and end the session, people, right? So in the fourth one, you can apply the reverse of the distributive law, right? I'll do it within 2 minutes, so just give it a try. And people, I need a feedback. How's this going on? Is it harder or is it okay? Okay, Nikini, how about others?
සර් මෙතන තුනක් දීලා තියෙද්දි කොහොමද කරන්නේ කියන්නේ අපි? දැන් common term එකේ එනේ.
Oh.
එතකොට සර් B plus B bar B plus එහෙම නේ සර් ගන්නන්නේ.
Oh,
B
ඒ
plus
වේලට
B
තමයි
bar.
ටික වරහන් ඇතුළේ ඉතිරි වෙනවා.
හරි සර්.
හරි. Right, okay, Sachintani, how about others? Yes, Lalindi, definitely. right? That is why the questions are there. So once we do with that, we'll go through. And Akila, how are you feeling? Right. Okay, so people, is everyone done with the fourth question?
Yes, sir.
Right, okay. How about others? All right, so let me do the fourth one for you. So in fourth, I'm going to take A dot B plus A dot B bar plus A dot C. So we can clearly see a common term, so it is taken out. So B plus B bar plus C will be there in the brackets. So the reason is distributive law, the reverse of it. Right, so Y plus Z will give you X dot Y plus X dot Z. Right, and then you can see inside the bracket, you can see there is B plus B bar, which is equals to 1. Right, so you can say equals A dot 1 plus C. So the reason is B plus B bar, I'm sorry, it doesn't matter whether you write it from B's, but
ඒක කම්ප්ලිමන්ට් ලෝනේ
complement law. Yes,
inverse එකනේ.
inverse law. Right, X plus X bar equals 1. Right, then you know, like 1 plus C equals to 1, right? That is from where? The identity laws, right? So A dot 1, it becomes 1 plus X equals 1. The identity law, finally, this is going to be A. The reason is X dot 1 equals X. So that is the final answer. Right, so people, you can do any corrections if you got. So I'm going to end the session from here, right? So we are going to do much more calculations by next week. And by next week, I'm trying my best to finish up the second lesson. So like we can move to the fifth lesson meanwhile when we are having the gates, right? So thank you very much, people, and have a very nice weekend, right? I'll meet you next Saturday for the same time, right? All right. All right, everyone. Thank you very much. Thank you very much.
Thank you, sir.
Right, okay, right, okay.